Of course, firefighters aren't the only professionals at risk of overheating. Welcome to the super hot world of ArcelorMittal's Burns Harbor Steel Shop in Indiana. Workers here suit up to keep cool around temperatures exceeding 3,000 degrees Fahrenheit.
The ambient temperature of the air that the crew works in can reach 130, 140 degrees Fahrenheit. Very high elevated temperatures. And then the radiant energy from the furnace is extremely hot.
The workers require multiple layers of heat-resistant clothing to keep this extreme heat at bay.
Wool coats, we have our greens, which are fire retardant, our cotton shirts, and behind this we have insulated underwear that prevent any kind of burning. They're fireproof.
Over all those materials, an aluminized-based overcoat. The aluminized coating on the outer garment is designed to reflect the radiant heat, and it's also designed to prevent any splashed steel that would come in contact with the employee. Kevlar on the inside is provided for strength and for insulation. It prevents the heat from transmitting through the garment.
It can get pretty hot when you're working in the summer. You know, you just have to pace yourself.
But the temperatures the workers face are nothing compared to the temperatures the steel-making equipment must endure.
Every transport vessel and processing vessel in the steel shop is refractory lined with different types of brick. We either use a magnesia carbon brick or an alumina brick, depending on the process.
To make new steel, the shop combines scrap steel with 2,400 degree molten iron and heats it to 3,100 degrees Fahrenheit in this basic oxygen furnace.
Behind us here, you're seeing our #1 furnace at the Burns Harbor Steel Shop.
In the furnace, a magnesia carbon lining is the protection of choice. The combination of magnesia's high melting point of roughly 5,400 degrees Fahrenheit and carbon's strength make them ideal for taking on the super hot.
It's about $1.5 million worth of brick, and that brick acts as an insulator between the 3,100 degree steelmaking temperatures and the steel shell on the furnace. On the outside, the shell is between 300 and 350 degrees Fahrenheit.
In addition, the steel shop lines the bricks with a layer of a steel-making byproduct called slag. This includes impurities such as carbon, silicon, and various oxides.
About 30 years ago, the furnaces lasted about 700 heats, 700 cycles between rebricking. Now we're able to make between 20 and 40,000 heats on a furnace lining by just using the waste material to coat the brick.
After the oxygen furnace, the slightly cooler steel will be further refined and transported in other brick-lined vessels before being allowed to solidify in a casting mold.
It's a finished product. We'll cut it to the length of whatever our customer wants and ship it from there. The slab temperature at this point is roughly around 1,500 degrees. It's still really hot.
But these steel slabs and other structural materials can also be destroyed by the superhot. The Center for Innovative Materials Research at Lawrence Technological University in Southfield, Michigan, conducts tests to find ways to keep that from happening. Inside this 18 by 8-foot chamber, structural materials are put on the hot seat to see how long they can withstand intense fire.
If you remember what happened in 9/11, the building itself did not fail because of the impact force. It failed because of the fire.
The purpose of the furnace is to simulate a fire environment, similar to what might happen on a building fire or a fire on a turnpike.
9 3,000 degree Fahrenheit flames heat the chamber to its 2,300 degree maximum temperature.
You need air or oxygen You need a fuel, which is the natural gas in this case, and you also need a source of ignition. With those three ingredients, you can have combustion.
What really makes this chamber unique is the fact that it can heat a 32,000-pound load to 1,000 degrees in 5 minutes.
Thousands of times more heat required than a home. The typical home furnace may operate with 100,000 BTUs an hour, where this furnace operates with 18 million BTUs an hour.
It also operates at much higher temperatures, requiring 12-inch thick insulation around the entire furnace. The center allowed the chamber's enormous door to open during testing, to give Modern Marvels a rare opportunity to look inside.
We intentionally have the furnace on very negative pressure right now, so it's drawing a lot of room air in to keep the area around here cooler. Otherwise, we might burn up some of the cameramen and myself in particular.
The door closes again, putting the pressure and the heat back on the concrete beam. While conventional concrete beams have steel rebar inside, this beam has been reinforced with carbon fibers instead. These fibers, developed at the center, are stronger and less corrosive than steel, but are also more flammable. After about 20 minutes of full heating, the concrete has crumbled and the fibers are singed.
So we need to make sure that the next step in our research is to identify new materials that we can spray on the top of the concrete beams to prevent the heat from reaching carbon fiber. Certainly the structure will last for a longer period for corrosion and fire.
That could also mean increasing fire evacuation times from 1 or 2 hours to at least 5 or 6 hours.
When you have more time to evacuate people, you can save a lot of lives.
While thousands of degrees cause destruction in this chamber, several 100 million degrees in here may be an answer to the Earth's energy needs. In 1980, an Atlanta, Georgia hospital admitted a man with a record-high body temperature of 115.7 degrees Fahrenheit. After 24 days of recovery, he was released. Super Hot will return on Modern Marvels.